Hello everyone. Welcome back to the Gist today. Today we'll break down the Nobel Prize in Physiology or Medicine 2025, what the laureates discovered, why it matters for health and disease, and how it could shape new therapies. No fluff, just facts. Every year, the Nobel Prize in Medicine honors discoveries that deeply advance our understanding of human biology and disease. In 2025, the prize was awarded jointly to Mary E. Brunkow, Fred Ramsdell, and Shimon Sakaguchi for their discoveries concerning peripheral immune tolerance. The immune system is extraordinarily powerful. It defends us from infections and cancers. But if it misfires, it can attack our own tissues. The work honored this year addresses the question: how does the body prevent its immune system from harming itself? Here's what the laureates unraveled. Earlier, immunology had focused heavily on central tolerance, the process in the thymus where developing T cells that strongly react to self are eliminated. But that didn't explain all autoimmune phenomena. The laureates' work shone light on peripheral immune tolerance, mechanisms outside the thymus that keep mature immune cells in check, especially in tissues. They identified a particular subset of T cells called regulatory T cells, or Tregs, which act like the immune system's brakes. These Tregs suppress overactive immune responses, preventing them from attacking healthy cells. A central breakthrough was tying this to a gene known as FOXP3. Brunkow and Ramsdell connected mutations in FOXP3 with a deadly autoimmune disorder in mice, called scurfy mice, that helped cement FOXP3's role in the development and function of Tregs. Meanwhile, Sakaguchi had earlier experimentally demonstrated that certain T cells could suppress autoimmunity. He laid the conceptual foundation for Tregs. In short, their collective work explained how the immune system is not just about attack, but also about self-restraint, maintaining a critical balance. Why does this matter? Understanding autoimmune diseases. Diseases like type 1 diabetes, lupus, rheumatoid arthritis arise when immune tolerance fails and the system attacks its own organs. Knowing how Tregs work gives clues to restoring balance in such conditions. Transplantation and graft rejection. One of the biggest challenges in organ or stem cell transplants is rejection. If we can harness peripheral tolerance, we may reduce reliance on lifelong immunosuppressants and improve graft survival. Cancer and immunotherapy. In cancer, sometimes Tregs dampen the body's anti-tumor immune responses. A better understanding of how to tune Treg activity could enhance immunotherapies by safely suppressing them in tumors without triggering autoimmunity elsewhere. Therapeutic innovation. Their discoveries paved the way for new lines of research: Treg-based cell therapies, gene therapies targeting FOXP3 regulation, and precision immunomodulation in clinical trials. So their achievement isn't just academic. It gives us tools and principles to design new treatments. Think of the immune system as a powerful army. Without regulation, it might mistake friendly territory, your organs, as enemy territory. Central tolerance is like training recruits in boot camp to know who is friend versus foe. Peripheral tolerance, via Tregs, is like having peacekeepers in the field who step in if troops misread a signal and are about to attack friendly forces. The laureates discovered these peacekeepers, and the control system, FOXP3, that programs them. What's next, and what should viewers watch out for? Clinical trials targeting Tregs in autoimmune diseases are already underway. Engineering or expanding Tregs ex vivo, outside the body, for therapeutic infusion. Using gene editing or biomarkers to modulate FOXP3, making Tregs more stable, safer, or more specific. Balancing Treg suppression in cancer settings without triggering autoimmunity, a fine line to walk. Exploring how peripheral tolerance interacts with microbiome, infections, aging, and chronic inflammation. The field is now much richer. The Nobel recognition acts as a signal to accelerate translational and clinical work. To wrap up, the 2025 Nobel Prize in Medicine went to Brunkow, Ramsdell, and Sakaguchi for uncovering how our immune system restrains itself through regulatory T cells and the FOXP3 gene, a discovery that reshapes our understanding of health, autoimmunity, transplantation, and cancer therapies. If you'd like a deep dive into any one aspect, say, how Tregs are being engineered for therapy, or how FOXP3 works at the molecular level, drop a comment below. Don't forget to like, subscribe, and share if you found this useful. Until next time, stay curious, science matters.